Hey guys, welcome back. In this video, we will understand what is Numpy and why Numpy is preferred for mathematical operations. For people who doesn't know Numpy, Numpy is a Python package basically used for performing numerical computations. It is one of the most popular Python package for machine learning. And also it is the first package people learn who are aspiring for machine learning engineer or data science roles. Now let us understand why should we use Numpy. Numpy is used for performing mathematical operations, and Python also have so many mathematical operators, as well as it has math module to do some complex operations also. Then why should we go for Numpy? There are basically two main reasons for it. One is cleaner syntax. Numpy has much cleaner syntax and also faster computation. So Numpy syntax is very clean. If you compare with the Python list operations and the Numpy array operations, both are completely different, and Numpy looks much cleaner and elegant. In machine learning, we have vectors. A vector is basically an entity like this. So in mathematics, we can represent like this, right? Now, if I want to do this in Python, how can I do this? In Python, we have a list. So I represent the same thing in the form of a list like this. Right? What about a matrix? If I want to create a matrix B, like 2, 3, 4, 5 square matrix, how can you represent in Python? So in Python, I can do a nested list. So the first row as one of the list and second row as one of the list, and both of them inside the main list. So this is my matrix here. So this is a nested list here to represent the matrix. Now, how can I calculate the square of this vector A in Python? This is my Python list. If I want to calculate A square like this, how can I do this in Python? So let's do this here. So what should I do? This is my list. So I should actually create a dummy list here for saving the square of this one, right? And then I will actually go through elements one by one for I in A. For every element in A, I will actually take one by one all the elements, and I will append this, the square of the element. So this is the square calculation. So this one, this total term I am appending into C. So by the end of this for loop, I will have C populated with square of all these elements. Okay. So this one will give me C is equal to 4, 9, 16. This is the output I will get. So if you see, we need to write this loop for actually getting the square of this element. Now, how can I do the same thing in Numpy? Let's say I have a vector 2, 3, 4. This is a vector. Now in Python, it is actually 2, 3 and 4. Whereas in Numpy, I need to do Numpy dot array of 2, 3, 4. So there are many ways for creating Numpy arrays, and this is one of the way. Okay. So if I want to do now square, A square, right? So let's say I will give some variable square of A is equal to, I can directly do like this. Whereas in Python, we have done the same thing using this for loop. In Numpy, it is just, now you can see that the Numpy has much cleaner syntax when you want to do these operations. And this is only for a single vector. If I want to do matrix operations, so let's say we have seen the previously, like I have a matrix B is equal to 2, 3, 4, 5, right? So now if I want to do some operation, like if I want to square this matrix, okay, B square. Now for doing this in Python, I need to have two for loops. One for doing this and one for traversing this one. So we have seen that in Python we represent this B as 2, 3, this is one list, and 4, 5, right? This is a nested list. In this nested list, we need to have two for loops. First for loop to traverse the outer list, and second for loop to traverse the inner list. Okay, so if I want to do the square of this matrix in Python list, I need to perform 2 times the for loops. Whereas in Numpy, it is still like this. It is still B double star 2. So now you can see it is very cleaner syntax. It is much more cleaner compared to Python. Now we will see the same example here in action. Okay, so let's suppose that I will just do import numpy as np. So this as is actually alias. So wherever I want to use this numpy toolbox, I can just directly use np as a alias for numpy. So I'll just do this, import numpy as np. Now I will do this one as Python list first. Okay, so this is my Python list. Now if I want to calculate the square of this, so square of a I'm creating an empty list here, and after that I will use a for loop for traversing through all the elements inside a. Now each element will come to I one by one. Now square of a I will append with I star 2. So this one will give me square of a. So if I print this square of a, I need not to write print statement in Jupyter Notebooks or Colab, so I can directly do like this. So you can see 2, 3, 4, it has printed 4, 9, 16. Now if I want to do the same thing in NumPy, I can actually do, let's say I am taking b this time, np dot array of a, because I already have a, so I'm just using that a converting into NumPy array. So this is one way of creating NumPy arrays. Now if I want to do square of this one, I can directly do b star star 2. So this is the square. I'm just printing it directly. I'm not saving into any variable. So you can see that it is actually saying it is an array. So you can see the output is same. So it is much cleaner in NumPy. So this is even simpler. This is only performing some square operation on a vector. If I want to do matrix operations, then things get uglier with Python. So I just want to show you one example of matrix multiplication with both NumPy as well as Python and see the difference. Let me just create a function called matrix multiplication, and I will take the variables a comma b. Now I'll write the logic for this matrix multiplication. So I'm assuming both are square matrices here. So I'll just take length of a as the number of elements, okay, in both. So for that, first thing is I need to create new matrix here for saving the output. So I'm just creating the matrix with zeros, NumPy zeros, 100, let's say 100. 100 by 100 matrix I'm creating, let's suppose that. Okay, so now if I want to perform matrix multiplication, we might have seen previously also, you can refer to other tutorials for doing that. We need to have 3 for loops for this, for doing in Python. So for I in range of length of a, so all are square matrices, so it doesn't matter you take length of a or b. So this is one for loop, and for j in range of length of a, so you can take the same thing. If you have different sizes, then you can take length of b here, and for k in range of length of a. So I'm taking same because all the matrices are square matrices. Now I want to compute matrix multiplication. So I will fill the values of C matrix one by one using I comma j, because these are traversing the rows and columns. Now this matrix multiplication is equal to addition of, because this is initially zeros in the C matrix, so I'm just adding these values to zeros. So a of I and then k multiplied by b of k and then j. So this will give me matrix C. So now I am returning matrix C here. This is my function for calculating the matrix multiplication. Now I will create 2 matrices and perform the matrix multiplication. So I'm just doing numpy dot random. So I'm creating the matrix with random values, 100 by 100, because I took the C matrix as 100 by 100. So that's why I'm doing the same here. Otherwise you can keep it as variables and then variable size and then pass it there, so that you can take any number of sizes. So for example, I'm taking 100 by 100 here. So this is all matrix multiplication in Python here. Print of matmul of m1 comma m2. So this is calculating the matrix multiplication in Python, and it has given me the output here. Now if I want to do the same thing in NumPy, so in NumPy you can see both are already NumPy arrays, so I need not to convert anything. NumPy also have a function for performing the matrix multiplication, so I am just using, in fact the name is same as above but inside the NumPy module. So I am just doing np.matmul m1 m2. So you can see both the outputs are same, but you can see the syntax. This whole function is used for actually matrix multiplication, whereas in NumPy it is just a single function available. So far we have seen NumPy has much cleaner syntax for performing the same operations. Now we will see the performance of the NumPy. So we told that NumPy is faster compared to Python. Let's see that. So let us see in the same matrix multiplication example, let us actually measure the time and see how much time both the functions are taking. So for that, what I will do is percentage time it. Okay, so this percentage time it is actually a magic function available as part of Jupyter Notebook or Colab because it follows the same principle. So this will actually measure the time for performing this particular line, which is a function call. You can see that it took 946 milliseconds. So the same thing I will do here, time it and perform this. Basically, to normalize it, it will do the same operation multiple times and it will actually take the average of the time taken. You have seen that it took total 946 milliseconds and 11.6 milliseconds per loop. Whereas you can see here, time is 1.3 milliseconds. So you can see the difference. One is taking 900 milliseconds, whereas the NumPy is taking only 2 milliseconds hardly. So you can see how fast the NumPy operations are actually. And this is only for 100 by 100 matrices. Whereas in machine learning, we deal with networks with millions of parameters. And we have seen in our previous lectures that basically in neural network, what happens is matrix multiplication or vector matrix multiplication or dot product, these kind of operations, right? And each neural network can have millions of parameters, deep neural networks. There are lots of parameters, lots of computations happen. And if you want to do it efficiently, you have to use NumPy because this difference in the time will increase exponentially if you go with larger number of parameters or larger matrix sizes. So you can see clearly that NumPy is way faster than Python. But why? Still we haven't answered the question why NumPy is faster. We have shown only NumPy is faster. So for that we need to understand what actually happens inside the NumPy. Okay, how NumPy is being implemented and what exactly happens inside the NumPy. So if you see, NumPy is basically implemented in C language. So whatever we are writing numpy.array, okay, these are actually C arrays. In C language you have array data types, right? So these are actually C arrays. Now we know that C arrays are homogeneous. What does this mean? It can only save data of single data type, right? That means these arrays or these NumPy arrays can save only one data type. That means if I want to save integers, it will only save integers. If I want to save float, it will only save float values. But I can't save the mixture of 1, 2, 3.5 like this. This is not possible. This is fine, this is fine. Okay, so that is what homogeneous actually means. Whereas Python lists are actually heterogeneous. These are actually Python lists. So in Python lists, we can save any type of data. I can save one integer, one float value, and one string I can save. So like this, you can have multiple data types in a single list in Python. Okay, so this is the main difference between NumPy arrays and Python lists. Because of this reason, NumPy is much faster. Because in C language, homogeneous data type means whatever data we are saving, it will be saved at continuous memory locations. Like this location is 1000, this will be 1004, let's say, this will be 1008, and I am saving 2, 3, 4. So this will be saved here, 2, 3 and 4. This is how it will be saved in NumPy. So if I know a variable a equal to like this NumPy array, I can get the elements of the other indexes also very easily. Whereas in Python list, the memory management is different. When I create a Python list like this, like a equal to 2, 3, 4. So this is Python. So if I create a Python list like this, it won't be saved in the continuous memory locations like this. What happens is, it will only save the address of these values in the A. So whatever A I am writing it here, so that will only save the address of these values. You might have heard that in Python everything is an object. So here only addresses will be there, and then these addresses will point to actual memory location where 2 is saved, actual memory location where these elements are getting saved. So it doesn't matter what kind of data you keep it here. So let's say I want to replace this with 2, 3.5 and then some string like this. So what happens is it will discard this connection and it will actually give the connection to 3.5 stored somewhere else. Okay, so same way this high will be stored somewhere else and it will discard this connection, it will give this connection here like this. As these elements occupy different memory, they are saved in different locations. It need not to be continuous in the same location, whereas the memory or the address takes the same amount, so they can be in the same place. When we want to traverse some value, if I want to print the output like 3 here, so what happens in Numpy is directly it will go to this second index, directly it can directly do 1 4 extra because it is an integer, so 4 bytes extra and it will fetch directly this value. Whereas I want to do the same thing, this 3 I want to fetch in Python, so first it has to go here and then from here it will go here and then it will fetch the value 3. So it is a 2-step process. Here is actually 1-step process, whereas here it is actually a 2-step process. So it is much slower in Python. So it has to go traverse through the addresses first and then it has to go to the location first. It is not a continuous memory location, so it uses more memory as well because it is storing 2 times, address one place and the actual value one place, and also it is slower. This is the main reason Numpy is faster. So it is same as the difference between Python versus C language. Everyone knows that C is faster than Python. Same rule applies here because memory management is different in both the languages, which is one of the reason Python is slower. Now I have one question. What happens if I want to store integer and float inside a single Numpy array? Can I store like this 2.5, 3.6 these values inside a single Numpy array? What happens if I do Numpy array of, okay, and then I will print a? What will be this output? What happens here? So the output will be 1.0, 2.5, 3.6. This will be my output. Is it? Because what it is happening here is typecasting. So it is converting this integer value also into this float value here. This is actually called implicit typecasting, which will automatically convert a particular data type into the equivalent different data type depending on the other elements provided here. You might have seen the typecasting concept already, so I don't go in detail into this, but Numpy inherently actually converts all the integers into float if at least one element is float here. Now the same way, what happens if I do 1, 2.5 and then high? So if I do this, what happens to this? Will it throw an error? Like, is it wrong? No, it is right only. It will not throw any error. But what happens is output will be 1, 2.5 high. So what happened here? All these are strings, whereas here all these are floats. Okay, so Numpy can also save strings. It doesn't throw any error when we are dealing with strings. So this is also implicit typecasting. So what is happening here is it is actually casting the data into a new data type without any loss of information. So that is what happening here, without loss of any information. If I want to convert these into float, there will not be any loss of information here. The same way, this is a string. How can I convert this into one data type where there won't be any loss of information? That is nothing but string, right? So I'm just converting into string. I can convert back into float or integer later, right? So there is no loss of information. So the implicit typecasting decides the data type, output data type, so as to keep all the information intact. That is the main thing. But you have explicit data typecasting where you can convert all these values into integers or floats or any other data type, whichever you want. Their data loss can be happening because it's your wish. You want to save all these things into integers. So this will go, this will go. So 2 and 3 only will be saved. The decimal values will go away, but that is your wish. Whereas the internal implicit typecasting always outputs into one particular data type where it doesn't leave any information loss. If you want, let's see this in action here. So let's say I want to just, I'll directly print here. So print np dot array of, so I will take 1 comma 2.5 3.6. This is what I have. Now let's see what is the output. So you can see the output has float values here. 1, 2.5 and 3.6. So the same way I will do print np.array of 1, 2.5, hello. If I do this, what will be the output? You can see that it has converted all of them into string. So 1 is still 1, it is not 1.0. It is still 1, but it is converted into string. Whereas here 2.5 and then hello is a string here. So you can see that in the above case, it has converted all of them into float values, and here it has converted all of them into strings here. So it will not throw any error here. So this is how the implicit typecasting works in Numpy, so as to keep all the information intact. So it won't be having any information loss. So with all the above examples, we can understand that Numpy is performing much better than Python if you want to perform the numerical computations like vector multiplications or dot products, or you want to do matrix operations. All of them are much faster in Numpy compared to Python. So that is one of the main reason Numpy is most popular in machine learning field, because in machine learning we deal with all vectors and matrices in almost all the algorithms, starting with linear regression to the end of deep neural networks. Any of the technique you take, inherently what happens is the matrix or the vector operations. So we need to perform faster computations over there because it has millions of parameters. We need to do faster computation, which is why Numpy is used in most of the toolboxes. That's all from this video. Thank you so much.